Mm. And I am live. That is pretty cool. And today is 18th of September 2025, Thursday. Yep, today is Thursday. And yesterday was the contest in which I got a positive delta. And it seems cool when I say positive delta, but it just means my rating went up, which is pretty cool. And let's just begin and start solving dynamic programming questions from CSES sheet. And I really just want to get this done. Getting this done is not the right thing. Uh, Lately, I feel like I have been operating on autopilot, and that has somehow taken away the humanity from me, and that is bad because I do not want to run on autopilot. So let me lay out the plan. I do not actually have a plan, but let me just lay it out. So, uh, currently it is August. Shit, it is September, right? Like I said, I have been working on autopilot. Right now it is September. And so September 18th of September, 18th of September. So there are about like 12 days remaining in September. And then there will be October and then November with a capital N and then December, 3 months. And if we say 30 days in all three of them, right? Positively speaking, hopefully we will get 30 days. So in total, we have 120, 90, 102 days in total, in which currently my rating is 1312, I guess. And from this, I have to reach, yep, like that. From this, I have to go up to 2000 plus. Hmm, that is something. And in total, I have 102 days left to do this. And what would be the things that I need to get there from 1312? Let me just confirm. It is actually my current rating 1312, 1316. Yeah, pretty much the same thing. 1300 plus or 1300 doesn't matter. 1300, and I have to get to 2000 plus. For this, I have 120 days left. I think thinking in terms of days is not pretty cool, and thinking in terms of weeks would be better. So we can treat these 12 days as 2 weeks, and then 4 weeks for each of these 3 months. So in total, 12 plus 2, 14 weeks. I think that is the spelling of weeks without weeks. So 14 weeks, and in this I have to climb up by 700 rating points. Positive delta, and that is so what. So currently I'm here and I need to get there. So what are the things that are not here presently, which would be required? I guess right now there are some concepts like dynamic programming, and then there is also graphs. And if you just go to the CSES or no, this competitive program, I think, or not just I think, I believe that if I master every topic in this book, that should be enough to get to a rating of 2000. That is what I believe. And with that belief, we can move forward. And also, if we do not yet know if that belief is correct or not, but whatever the case, we will be learning new things and it is net positive effect. So we can move forward with that belief. So our goal, goal, yes, goal is to understand all of these topics completely, so that these things seem as natural to us, to me, as if we are eating food, right? Like we can do this shit on autopilot kind of thing. And what are the topics? If I speak for myself, for me, this thing introduction, like that is introduction. Time complexity. I have to work. Yeah, I will have to read a bit more on time complexity so that I'm very, very comfortable with calculating time complexities. And sorting, yes, I'm pretty much done with sorting. Yep, there the number of elements. Yep, but there are some edge cases in sorting, like wait, first of all, before delving right into what is sorting and data structures, let's see how much is there in bulk. So I have an approximate idea as to what these things are on this page. And for this, we have done the greedy algorithms, we have done dynamic programming, we are literally doing dynamic programming right now. And then for amortized analysis, yep, I only have a clue as to what this means. For example, like in a vector in C++, when we append new elements, the amortized time for that is A of big O of n. And that is amortized analysis because most of the operations are pretty quick in constant time, but some operations take n time. So in total, if we do calculate the time complexity, it would turn out to be constant or maybe log of big O of n or something. That is amortized analysis. And yes, I will have to read up on that. Range queries, yes, shit. On range queries, there are static range queries, and I've done this part like just day before yesterday. I did a question on CSES, two questions. First one is like very easy. Using prefix, we can find sum in ranges, and then the second one uses sparse table for calculating the minimum, and we can use the sparse table for calculating also the maximum in a given range. So that would also be done. But yeah, there are binary index trees, segment trees, and additional techniques. So yeah, these two things are left. Let's write them down as we go. And let's create a couple of columns. Because if I actually want to get to a rating of 2000, if I'm not joking, then we have to be very strategic, comfortable, um, slight, slight knowledge, and then like unknown. And we could also have represented this in a circle, I guess. Everything that I do not know would be outside of the circle. Everything that I'm comfortable with would be like in the middle of the circle. And everything that I slightly know would be like on the fringes of the circle. Right, so let's first fill this unknown column. Yep, we can do that. Dynamic programming. Yep. In the unknown, I have amortized analysis, and I'm being very, very harsh with my judgment as to what I consider unknown. And yeah, amortized analysis, same queries, and with range queries. After that, bit manipulation. I am good. I would say I'm better than average in understanding bits, in imagining bits, but I have not specifically read on bits because of the work that I've done in assembly, because of some codes that I've written in assembly, my understanding of bits is good. Not that I know about tricks, but if my model of thinking in binary terms is pretty cool. It is pretty good. So, but still I would keep, so I can keep this one in bit, slight knowledge bit. And not because I do not know, well, I do not know a lot about bit manipulation, but the advantage that I have with bit manipulation is that my mental model to work with bits is pretty cool. And graphs, yes, slight knowledge. I worked a bit with graphs. I've done a few graph questions, graphs, but I am like totally unknown. Totally, I like literally do not know these other algorithms. I have done depth first search, breadth first search, and I'm actually pretty comfortable with these two, DFS and BFS. But with other things like sorting paths, for tree, I've literally not read anything for trees. I have only done questions on trees. I have not read anything, so that is bad. And then spanning trees, no, I have like literally no idea. Two sat, what is the satisfiability problem? Connectivity, strong connectivity, strongly connected. Hmm. Tree queries, path and circuits, lowest common ancestor, subtrees and paths. And in yesterday's contest, there was a question which took me more than an hour to do. But then when I read the editorial today, it said that we had to use something called topological sort. And I think topological sort is there in this book at some point. I think I have read about topological sort here. So yeah, the thing was I had to use topological sort to solve that problem. And if I had known about topological sort, I would have been able to do that one faster. So yeah, that is something I would need. Graph algos, totally unknown. I don't know anything about these graph algorithms. And then number theory. Hmm. I have gone through the whole chapter on number theory and combinatorics on one of the streams, on a few streams, but I've been largely unable to apply that knowledge to something. But modular arithmetics has been very useful, I would say, and primes, combinatorials, inclusion, exclusion, they have been slightly useful. Yeah. And then matrices, probability. Yep. No idea how to work with probabilities. Markov chains, shit, there was a Veritasium video on Markov chains. Random variables, events, calculation. I would say I have slight knowledge in probability. Or let's be harsh and put this into unknown. And then matrices, I don't even know what linear recurrence is. So let's put that into unknown. And then game theory. I know a bit about game theory, I would say. But as to what game theory is here is a different thing. So we can put this also into unknown. And then string algorithms, also unknown. Shit, I don't know anything. Square root algorithms, I don't know. Square root algos, also unknown. And then segment tree, again unknown. And geometry, yes, I would have to work on my geometry a lot. It is, but geometry questions are easier than average questions because it is easier to visualize. Sweep, line, algos, also unknown. Yeah, so shit. There's a lot that is unknown. And with comfortable, it is empty. Wait, let me put something into comfortable just for my self-confidence. Yeah, I'm comfortable with sorting, binary search, everything like that. And data structures, nah, I cannot put it there. Complete search, greedy and dynamic. I guess when I'm through with these dynamic programming questions, I will be able to put dynamic programming in the comfortable section. But once I have gone through all of this, only then, but not now. Slight knowledge. I guess medium would be nice, and if this is medium, then graphs has to go. Greedy algos and DP, DP, just DP. Yeah, I'm only comfortable with sorting. Okay, with that, let's make this strategy a bit more concrete. So there is quite a bit that has to be read. And there are 14 weeks to do all of this to get from a rating of 1300 to a rating of 2000. And there are 12 days left in this month and 30, 30, 30 for the next 3 months. October, November, and December. Currently, it is September. So for now, not for now, the main right now, the main goal is learning. Right now, the main goal is learning, and after that, the goal is increase rating. Right now, the goal is not to increase rating because I just do not have the enough knowledge. I don't have enough knowledge to increase my rating. So that's it. But the goal right now is to just learn and grow. And after that, the goal would be to increase my rating. And I have to specify a time period for learning. I mean, learning is kind of throughout this whole time, there is going to be learning, but heavily, I'm not focusing on increasing my rating right now. And I would say, even if, let's say, my rating drops from 1300 to 1200, and then I give contests very, if my contests start going very good, then I think I would be able to reach 2000 from 1300 or 1200 in 1.5 months. So this period when I want to increase my rating would start from mid-November to end of year. From mid-November to the end of the year, I would focus more on increasing my rating, but for now, that is not the case. For now, the goal is to learn. Learning is the main goal. And time period is from right now till, like, this learning is going to be throughout. Okay, now since right now the goal is to learn, let's make a little bit of strategy to make this more concrete for learning. So these are the topics that I do not know, and these are the topics that I have slight knowledge. So we need some plan for learning and some strategy then for increasing the rating. These things are literally unknown. And there are 24 hours in a day, and I have heard, I saw a person named Benjamin Heap. He is a neuroscientist, PhD, and he says when you are learning, sleep is good. So I will increase my sleep from whatever 6 or 7 hours I was taking. I will try to get it up to 8 hours. So if we are literally going to the roots, then from 24 hours, 8 would go to sleeping. And I think thinking in this manner is bad. Instead, I should think on topics instead of, yeah. So what is going to be the plan for learning? Right now, there is dynamic programming. I think, okay, let's make a goal for the rest of the 12 days for this month. I will have to complete, of course, all of these dynamic programming questions. And yes, the goal is for learning. So dynamic programming, I will go through all of this. And since I'm going heavy with dynamic programming right now, and the material that I have read on dynamic programming has been from the CLRS book. Right here, we go there. The only material that I have read has been from this CLRS book. Right here, dynamic programming, and from the competitive programmer's handbook. Here, dynamic programming. And I think there are two more sources from where I should read about dynamic programming. Not two, but only one. Yeah, only one source, and that is CP algorithms. Because this book, the Competitive Programmer's Handbook, gave me a basic understanding of what dynamic programming is for competitive programming, and then this book gave me a comprehensive understanding of what dynamic programming is for a research level thing where we have to state proofs and everything. And now I want to mold that dynamic programming concepts which I've learned from this chapter into more into something that is more specific to competitive programming. And for that, I would have to go through these things here in the CP algorithms thing. Yeah, CP algorithms website. Practice problems, yep. And then DP optimizations, divide and conquer, and then Canute's optimization. Because right now, since I've already gone through this whole dynamic programming chapter from the CLRS book, I have concepts of how as to how to think in a dynamic programming question. And now I want to mold those concepts into something that is more similar, that is more fitting for competitive programming. And also I'll be doing these questions on site. So in these 12 days, right now it is Thursday, and it's Thursday, Friday, Saturday, Sunday, 4 days. And how long is this thing? Calendar. Yes, bring out the calendar. Bring out the calendar. Time and date. September. Yep. Today it is 18 and 30. So I'm saying till Sunday, let me finish everything that has to be with dynamic programming. I will go through all of these things and all the CSES dynamic programming questions, and I think that would be enough. Or there are also, if I need more questions, which I will need more questions because these are not enough, there are BP questions on ad coders, educational DP contest. No, this was not the thing. A friend of mine sent me a link. Yep, it is lost. Yeah, there is a page on ad coders. Yes, problems DP. There is somewhere on ad coders a whole page which has to do with dynamic programming questions. And yeah, so when I'm done with CSES, I will go through those questions and do them. And yep, I think am I overestimating myself? From today, Thursday, Friday, Saturday, and Sunday, 4 days. And reading this, going through this is pretty easy. I can say I will be reading one article every day, and that would be that is not too much to ask for. But the questions, I guess I can do this because what else is there to do? So yeah, I think that would be enough. I will be able to do all of these questions in the next 4 days, today included. Yep, so that would be it for till Sunday. And then for the next week, from Monday till 28th, what will I do? I guess I can pick another topic. Let's go with graphs, because graphs, as you can see in this competitive programmer's handbook, takes up a big portion, a big chunk of this whole thing, right? Ends at chapter number 20 and begins at chapter number 11. So there are like basically 10 chapters on just graphs. So we will go through graphs then, and I think that much strategizing is enough for now. What we can take away is we have to solve the dynamic programming questions and read about dynamic programming from here. So that is cool. Now let's get down to solving these questions. And today I feel a bit fresh, so let's see why we were getting wrong answer for this question. Let me turn off my Tmux skill server, Tmux set, attach CSES, cddp, n. Uh, there are some updates. There always are some updates somehow. And then this question. Solution has already been written from yesterday. Let's read the problem statement again correctly. Your task is to count the number of ways we can divide numbers from 1 to n in two subsets into two sets of equal sum. So when n equals something, we have been given all the numbers from 1 till n. If n equals 7, we have been given all numbers from 1 to 7. And what we have to do is these numbers from 1 to 7, we have to put them into two different sets, and the sum of one set should be equal to the sum in the other set, and that is only possible. Let's say n is something, and if we find Sn, that is the sum of the first n numbers from 1 plus 2 plus 3 plus dot 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 plus n, this thing is going to be equal to n into n plus 1 divided by 2. This is going to be the sum. So we have Sn when we have been given n, and this thing Sn, we have to divide these numbers into two sets, and this is only possible if Sn is even. If we divide Sn, this thing should be an integer, and if Sn is odd, we cannot divide Sn into two groups and say that their sum is equal, because Sn is odd. We only have integers, so we cannot divide Sn into two groups. For example, when n equals 2, Sn equals 1 plus 2, which is 3, and when we have a sum of 3, we only have two numbers, two integers, 1 and 2, and how are you going to divide these into two groups? Here the sum is 1 and here the sum is 2, and the sum is never going to be equal. Since the total sum is odd, we cannot divide this odd sum equally into two halves. So this thing will only work when Sn is even. And when Sn is even, we can see that the sum that this group is going to have, that these groups are going to have, is going to be Sn divided by 2. And to get up to this target sum of Sn divided by 2, the numbers that we have are 1, 2, 3, 4 dot 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 till n. So we have to find the number of ways through which we can get to this sum using these numbers, and which is very similar to coin change. And this is like basically coin change, but the only difference is when we have, let's say, n equals 3, then the sum is 1 plus 2 plus 3, which is equal to 6. And then you can say, since Sn is 6, the target sum that each set is going to have is going to be 6 by 2, which is 3. And how many ways are there to get to a sum of 3 when we are using these three numbers, 1, 2, and 3? Well, there is one way when we use 1 and 2, and then there is another way when we use 3. And we have to see that when we are using these two numbers to get to a sum of 3, this third number is left alone, and if we put 1 and 2 in one set, this third number is going to go into the other set. And since these two add up to 3, and we know that the total sum is 6, then by default, by forceful measures, the sum of this other set is also going to be equal to 3, which is 6 minus 3. So here we saw that the number of ways is 2, and these things are paired up. This way of representing 1 and 2 is paired up with 3 on the other side, and we have to therefore count the number of pairs, and the number of pairs is going to be the number of ways to represent divided by 2, because that is how many pairs there are going to be. When you choose one representation, then other representation is going to go into the other box, and we do not want to double count. Therefore, the number of ways to get up to a sum of Sn by 2, divide whole thing by 2. Yep. And let's implement this thing and see if it works. I mean, yesterday it was not working. I don't know why. It was like giving wrong answer for some specific numbers. Let's see. Int n. See, in n we have taken n. Now long or int sm, the total sum is going to be n into n plus 1 divided by 2. That is going to be the total sum. And let's say long rest equals 0. That is the response. And if we have to see that Sm is even, if Sm and 1, this part here is checking if Sm is even. If Sm is even, then we will do something, else we won't do something, and we will keep response equal to 0 as it is, and then at the end see out response. Now if Sm is even, what we will do is we will create a vector of integers, and also let me have const int m equal 1 e9. Since this number can be very big, we will have to keep taking modulus. And table, we will have a table, and the target sum is going to be res is going to be sm by 2, right? As we saw here, the target sum is going to be sn by 2. Let's just call it sn instead of sm. Sm with sn, so sn by 2, that is going to be the target sum. So the size of our table, let's call it dp for normalcy, but we will not go with the dogmatism. So let's use tb as in table, and sn plus 1 because that is the sum that we want to get. And here we know the number of ways to get to a sum of 0 is 1. That is it. And then we are saying for int I equals 1, I less than equal to n I plus plus. That is when we are using the first I numbers from 1 to I, then how many ways are there to get to a sum of S? And S will go from big to small. The largest value that of S that we care about is Sn, and from there S will go on while S is greater than I, because if S becomes lower than I, then we cannot use the ith coin to get to a sum of S, and therefore it wouldn't matter, right? Yep, and then here S minus minus, and we will say that tab S plus equals tab S minus I. That is it, and then tab S modulus with M, and the answer is going to be response tab, not S, but Sn. And hopefully this works. Okay, it just keeps on compiling and it outputs the wrong answer. Yes, it outputs the wrong answer because we have to do Sn divided by 2. Yes, I did the same mistake yesterday. And divided by 2 can be written as right shift Sn by 2. Right shift Sn by 1, which just means divide Sn by 2. And here, since we saw that the answer is going to be the number of ways, let's say x number of ways divided by 2, and we have tab Sn, the number of ways to get to a sum of Sn. Now divide that by 2, which is just right shift this number by 1. And hopefully this does work. That is correct. This does work. And yesterday we were getting wrong answer for a few submissions. Let's see, specifically, I guess it was 107 that we were getting a wrong answer for. Yep, 107. Let's try that. In G++, the name of the question is two sets dot slash out 107, and we are getting 899, which is wrong. We are getting the exact same sum as we were getting yesterday, but we are supposed to get this. Still, there is no improvement in this. And even here, when we input 112, 112, we get 4791 something, which is what we were outputting yesterday, and that is not the correct output. Wait, if we take this number and we do this number multiply by 2, what do we get? We get, nah, we do not get this correct answer. We get something else, which is this. Print the answer modulo 10 power 9 plus 7. Am I doing something bad? What is the maximum value that S can have? The maximum value that S can have is, since N can at maximum be equal to 500, N at maximum is going to be equal to 500, then the maximum value that Sn can have is 500 into 501 and divided by 2, which is just 25000500, right? Yep. And divided by 2, which is 1252550, which is well within the range of an integer. It is not even a million. So Sn is not going to be very, very big. So that is cool. Maybe if I make this thing a long, I do not think that there is some logical mistake. There might be some language level mistake there. Still the wrong answer. Sn plus 2 tab 0 equals 1. I goes from 1 till equal to n. Yes, that is the number of things that we have. Wait, there might are we very, very sure about the hypothesis that we made earlier, that when we have Sn, answer only exists when Sn is even, and we can divide this into two parts? Yes, we are very, very sure about this because we must use every number from 1 to n, and the total sum is going to be Sn, and our goal is to divide these numbers into two groups in such a way that they sum up to be equal, Your task is to count the number of ways this can be divided into two sets of equal sum. And here we are hypothesizing that if there are x ways to get to a sum of Sn by 2, then whenever we get to a sum of Sn by 2, let's say we use a set of numbers xi, that would be the ith way to get to a sum of Sn by 2, and we used xi set of elements, and this set must be a subset of all the numbers from 1 till n. And if we want to find the other set which comes with this, with the set which makes a pair with this, let's call that xj something, that would be equal to 1 minus n, 1 comma n, 1 till n, all the numbers from 1 to n. From this set, subtract xi. This would give us all the elements that we didn't use in this set xi, where we are getting to a sum of Sn. And this set xj would be the other set with which this xi set can be paired up with. And this would always be true because we know that the total sum of this set from 1 to n is Sn, and the total sum of this set xi is Sn by 2. And when we subtract from Sn by 2, we get Sn by 2. So this thing is Sn by 2, and this thing would be counted, this thing would be counted, and they would be counted separately. And if we have c number of ways to get to a sum of Sn by 2, the number of pairs in this c is going to be c by 2. All of that is very solid, but it's still, I think there is no mistake in the logic, but there is some mistake in the implementation part. Okay, let's go through this step by step. Taking in the input is fine. I mean, yeah, this thing is not causing any error. We can say that for sure. Taking in the input is very fine. And then calculating this thing, I don't think there is any mistake with this, because first I am multiplying n into n by 1, and then I am dividing this by 2, which we can say like this. Right shift this whole thing by 1. And then this response equals 0 initially. But then we check is Sn even, and this method of checking if Sn is even is cool, because this thing checks if it is odd and this thing is not. So not odd, then it is even. And how does this check if Sn is odd? By taking its and if I take and of Sn with 1, if the last bit is 1, then Sn must be odd, and if the last bit is 0, then Sn's last bit must have been 0, which means Sn was even, and that is what we are checking for. If this thing returns 0, then the not would turn it into a 1, and we would come inside this statement. Sn by 2. Sn by 2. Yes, that is going to be our target. We do divide Sn by 2, which is we are just right shifting the bits in Sn by 1 to the right, and then our target is Sn plus 1. Then we create a table. Sn plus 1 is the size of the table, and tab 0 we are initializing that the number of ways to get to a sum of 0 is 1. You just do not choose any coin. That would be the number of ways to get to a sum of 0. And then we are ranging our coins from 1 till equal to n. And we are going from the right, from the maximum sum to the lowest, into the lowest indexable sum that could be affected with this current ith coin. Yes. And then we are adding the number of ways to get to a sum of s using this ith coin, or the first I coins. That is, this is also correct, and this is also correct. I don't know what the mistake is. 107, still nothing. And yeah, have I exhausted the possibilities of mistake in this? If I have, I really do not want to go to ChatGPT for this. Like, tell me what is wrong with this, something like that. Which distro? So it is Mac. I'm using a Mac. And can we do CP in Java? Yeah, you can do CP in anything. You can do CP with Guns and Roses. That is pretty nice. And Sail, which distro? Mac. And this is like pretty cool. The terminal is Ghosty. You can use Ghosty terminal. And yeah, you can do CP in Java, competitive programming, not CP, competitive programming in Java if you want. But the main goal is to get the program right and understand the concepts and not make silly mistakes like I'm doing right now. Why? In these specific cases, it is breaking somehow, even though everything seems like bulletproof in this thing. Okay, I guess instead of wasting time now since I've been trying to get this right since yesterday. And I know for a fact that even if I think about this for days, I won't be able to come up with a mistake because everything here, according to me, is bulletproof correct. And I don't think there is any mistake here. So we can ask the AI if there is something wrong. So yeah. Okay, instead of just sending in the code and asking what is wrong with this, what we can do get is ask specifically, is explain the logic specifically, and then ask, is there something that is wrong with this logic? So I have been given numbers from 1 to n. I've been given integers, positive integers from 1 to n, and my goal is to find the number of ways to these numbers into two sets such that the sum of all the numbers in one set equals, and yes, I have made a mistake, equals the sum of all the numbers in the other second set. And I must use and whenever making a pair of sets, every number must be in every number can only be has to be a part of exactly one set, either in the first set or in the second set, and not in both the sets at the same time. And I sent in this. Now that is the problem, and my solution is a bit different. Where you learned whole DSA in brief, I would say from this book, CSES, CPHB, Competitive Programmers Handbook, this thing, and this thing for the theory, and then not just this thing, but yeah, you can begin from here. And for questions, you can go to the sheet, competitive TLE eliminators, CP31 sheet, and shit, this thing never loads. It is loading now, and you can start solving questions from 800 rating and go up slowly. So this is for questions, and this is for algorithms. And these chapters in the basic techniques, you can just read all of these, and yeah, that is what you can do. Wait, is my okay? My OBS is fine. Shit, I thought my stream went down. No, yo, yep, cool. You can grow. You can become very, very good. You can maybe even someday beat a certain man whose name is Gennady Korotkovich. And yep, so my strategy is this. Let's say Sn is the sum of numbers from 1 to n, and then we would only be able to make two sets have the same sum if this Sn is even. And from there we can say that the only sum that those sets could have is going to be Sn by 2, since we want the set to sum up to the same amount, and the total amount that we have is Sn. So they should only have their sum exactly equal to Sn by 2, exactly equal to Sn by 2. And this is a basic point change problem where the coins are 1 to n and the target sum is Sn by 2, and we have to take care of double counting, double counting. And then let's say we find that there are x number of ways to get to a sum of Sn by 2 using points 1 to n. Then the number of ways we can make a pair of sets is going to be x by 2, since every way in there has a course, every way to get every way in x to get to S n by 2 leaves uses some elements, some numbers from 1 to n, and leaves some. The numbers that were left are also going to be counted as a separate way, and we want to pair them up. So the answer is going to be x by 2. Is there a mistake in this logic? Let's see. Yeah, shit. Indisciplined engineer. Any tips? I can do 800, 900 problems with a little effort, but I'm finding 1000, 1100, 1200 to be tough. So it is fine to take help from tutorials. Yes, of course. Do not feel bad about taking help from tutorials, because you do not have to invent every algorithm that you are going to learn in your life, right? It does feel bad and you do feel guilty whenever you see a video explanation or maybe the tutorial, but the goal is for you to understand that thing and not to discover that thing on your own when you read the question. So if you are stuck on a problem for, let's say, 30 minutes, then it is very, very okay to just go and see the tutorial and then implement it on your own, and make sure, for me, the main thing is you have to make sure that you understand why this algorithm that you saw in the tutorial, why does it work? That is the main thing. You have to be able to argue with someone that this algorithm that you read from the tutorial is correct, and you should be able to prove to yourself and to someone else that this algorithm is going to be correct, either using mathematical induction or any method of proving. You have to be able to prove to someone that this thing is correct. And yeah, you can see right now I was getting a wrong answer for this question. So, and I know for a fact that even if I think about this for longer, I won't be able to find any mistake in this because I think wholeheartedly that this is completely correct. So I went to the AI and I didn't just copy paste my code. I explained my whole reasoning, the question here, and then my reasoning for finding the answer. And then I'm asking, is there a mistake in my logic? And your logic is correct. And common pitfalls. Yep, there might be some pattern which I am mistaking, which is very common. And after I've read this tutorial or anything, I won't make that mistake again. So that's cool. Why our reasoning is right. Sn equals the total sum n into n plus 1 divided by 2 is odd. There is no way to split them into two equal sums. Yes, that is also correct. I am checking it for here, right? And then if Sn is even, any valid partition corresponding to subset A, which is a subset of 1 to n, all the elements. If this equals Sn, then let X be the number of such subsets which equal to Sn by 2. Yes, every such subset A has a distinct complement. Yes, shit, complement is the right word. Instead of saying something like this, Sj, Xj, and Xi, complement is the right word, is the better word for it. So yeah, every subset comes in a complementary pairs, A and complement of A. Each unordered pair, this thing is counted twice in X. Unordered, because we are saying we have to find the unique ways and the order does not matter. It's counted twice in X. Once as A and then as AC. Therefore, the number of ways should be X by 2. Yes. Yes. Things to watch for. Make sure you mean or unordered pairs of sets. If the two sets are considered labeled first set versus second set, you should return X not divided by 2. But we have to return X divided by 2 because the order of the sets does not matter. Like in the example that they have given, here we have 167 on as the first set and then 2 3 4 5 as the second set. But if we were to change and say 167 is the second set and 2 3 4 5 is the first set, that would still be considered as the same pair and nothing would happen. So the sets are unordered in that sense. X will always be even. Sn is even because of the complement pairing. So dividing by 2 is integral. No factorial answer. Yes. Implementation details. Computing X is a subset sum counting problem. Typically DP, dynamic T, is the number of ways to pick sum with some T. DP0 is 1 in initial. Yes, that is also correct. And the coins are going to be 1 to n. Do not do for T. Target dpt equals dpt minus c, then X equals dp Sn by 2. Answer is X by 2. That is correct. Complexity is going to be n cube. Yes, it is going to be n cube because Sn is n into n by 2, n into n plus 1 by 2. In the worst case, naive sense, because Sn is n square. Wait, is there something better to do? Give a small efficient DP algorithm in Python or C++. Okay, so ChatGPT is also saying that this implementation is correct. So what is wrong? Let me just paste in the whole code because at this point we can see that CSES is saying that the answer is wrong. And I'm very sure that this is going to be some very stupid mistake, silly mistake, maybe something I'm writing wrong. Is my station, and I am getting wrong answer for n equals 107 and also for some other numbers. I'm pretty sure. Yep, you're welcome. This is going to be some stupid mistake. I see the problem. Your logic is fine, but the implementation has two subtle bugs. Dividing by 2 with modulo arithmetic. Okay, shit. I will not look. That makes so much sense. I have to find the complement of 2 and multiply this thing by the complement of 2 modulo complement of 2. Shit, yes. Yeah, shit. Okay. So this part is, all of this is correct, but the mistake is here with this division part. I cannot divide this thing by this. What I have to do is power 2 raised 2 to the power of m minus 2. Why is it not included? Include algorithms. I think that is the thing. Okay, let me start my LSP. Include algorithm, not algorithms. Okay, where is POW defined? POW is defined in C maths. Okay, after multiplying, I will have to take modulus with m. Wait, why is this wrong? Binary expression, why is wait a minute? I'm getting call. Okay, wrong. Okay, it is wrong somehow. Let me just pick up my phone in a minute. Yep. Okay, it is fine. And is my camera fine? No, shit. It is messed up. Shit, my camera is actually messed up. It is fine now. Yep, totally fine. And we can begin. Wait, let me go and I will be right back in a minute. And I am totally back. That is pretty cool. Good afternoon. Hello. Yesterday's contest, how was it? Yeah, it was fine. It was fine. Yesterday contest. How was your delta? Positive, negative? Okay. And here we have to use something called modular inverse. Yeah, we have A divided by B mod M, which is not equal to A mod M divided by B mod M. Nope, these two things are not equal. What is equal is is 2 raised to the power of M divided by 2, and shit, positive. That is pretty cool. And wait, someone is at the door and I'll be right back. My bad, sorry. I am extremely sorry. I will have to end the stream right here today. And yep, yeah, I'm sorry for that.